Stress-free learning with
Nyam.
create a better tomorrow. You get the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
Do sharks complain about Mondays? No! They're up early, chasing things, biting things, eating things, showing people that they are sharks. A damn shark. Why can't you do the same? Okay, boom! Okay, we're about to get started. Today, what are we doing? Today, we'll be doing differentiation. That's what we're doing today. That's the good stuff. That's the easy stuff. Those are the free marks, man. Be excited about this. Why are you not excited? It's differentiation. Okay, let's get down to it. Let's get started. So, there are two types of two ways to differentiate. Okay, the first one is using first principles. First principles is that long equation that I'll write down soon. And the second one is using the differentiation rules. There are specific rules that you can use so that you don't have to go through the whole first principles, right? So first, let's look at first principles. What's first principles equation, right? Let me write that down. First principles. Right? So first principles, what is the equation, right? I'm not going to write it like the regular. So how do I write derivative? How do I show that this is the derivative of f? So example, a function f of x. Find the derivative of f of x. So this is how I'll show it. F prime of x. F prime is shown by that small little line, and not to be confused by f inverse, which is f to the negative 1. That's a different story. This is prime. This is a small little line just before the bracket with the x, right? F prime of x is equal to limit as h approaches 0. So as you can see, the limits are coming into play now. Limits of a as h approaches 0 of f of x plus h minus f of x over h. So that is the basic first principles. That's what first principles looks like. So if you plan on going to university and doing engineering, commit this to memory. Or I'm assuming if you plan on going to university and doing anything with maths, commit this to memory, because I can tell you now, you will probably need it. So if you know it now, you won't have to cram it later on when you get to university, right? So first principles, that's the equation. Okay, so that's the equation, right? So let's do an example so that we can see what it looks like. So example 1 in first principles, they say f of x is equal to 2x cubed plus x. Okay, so I decided to do a little bit of a more complex one as the first example, so that, because this stuff should not be that complicated, because this is guaranteed to be in your exam. This will be 5 marks, and it will be the first question in your, under that section. What's that section called? Anyways, in your paper, it's probably question 6-5, right? So this is a little bit of a tough question, but it's not that hard. It just needs you to think just a little bit, right? So let's get started, right? So what's the first step? The first step is write down my formula, right? I'm gonna write down, but I would write it down, but it's right here, right? So, but you need to write down your formula first before you start this. So I'll write down my formula, right? Then now I'll write down f of x plus h as my components that are in my formula. F of x plus h. So what does that mean? It means wherever I see x in my function of f, I'll replace it with x plus h. So what does that look like? 2 of x plus h to the power of 3 plus x plus h. So this is basically what f of x plus h means. So that's what you have. So I could leave it like that, but I'll rather solve this out first. Solve what I have here before I substitute it into the equation, so that I don't have to continuously write limit as h approaches 0 while still solving this whole thing, right? So I'll solve this first, and then I'll substitute it back inside. Right? So what's the step? I mean, you should know these things, but let's just do it together. So I'll separate it and make it f plus x plus h, right? So I separated by x plus h to the power of 1, x plus h squared. Because if I multiply these two back together, it will become x plus h cubed. Okay, so what do I do? Now I can work with that x plus h squared because I know how to do that, right? X plus h doesn't change. So what do I do? How do I solve for that? I say x squared. I square the first one, so it becomes x.
Patience. Patience is the most important thing I feel like ever. You have to be patient in life and in general, like anything in life. For anything in life, you have to be patient. You have to carry on working hard, but you have to be patient because it might not happen right now. It might not happen right away. So you have to be patient.
Square, then I multiply the two values. So x times h multiplied by 2. Don't forget the 2. So it will be x times h times 2. So it will be 2xh, right? And then I square the last one. H squared, right? Plus x plus h, right? That's what we have now. So we're getting somewhere, right? We're getting somewhere. So what do we do now? This is equal to, now I have to FOIL. But do you see how large this number is going to be? So first principles requires a lot of work, but it's systematic work. It's not new work. It's not stuff that's complicated. It's systematic work. You know, you after this you have to do this, after this you have to do that. So this is what we have to do. Now we have to do FOIL, right? So if I'm doing FOIL, my answer, what I will have over here is x cubed plus 2xh plus xh squared plus x squared h plus 2xh squared plus h cubed bracket plus x plus h, right? That's the stuff that's on the outside, right? So now this is what I have. It looks a little bit complex, but it's just a matter of combining your like terms, right? My like terms, what are my like terms? X squared h is a like term over here, x squared h. And then x h with h squared as a like term over there, right? So those are the like terms. So let's combine all the like terms and see what it looks like. So I'll bring all the cubes to one side. So I'll bring x cubed plus h cubed, right? That's what I'll bring this side. So now what do I have? What do I have? I have plus x squared h plus 1 over here. It will be 3x squared h, right? If I combine these two, it will also be 3x h squared, right? I've already eliminated h cubed, right? Because I already put it there, and I combined all these other ones. So I have everything to put down together. Plus x plus h, right? So what am I left to do? Now I must multiply through by 2 so that we have that 2 inside there. So it'll be 2x cubed plus 2h cubed. 2 times 3 we have plus 6x squared h plus 6x h squared plus x plus h, right? Now we are somewhere, right? We're getting somewhere. As you can see, this takes a lot of time. You have to be patient and you have to be concentrated and focused so that you don't make a mistake and lose 5 marks for something this easy. So now what do? I already know f of x. I don't have to solve for that. So let's substitute into our equation. So what is f prime? F prime of x is equal to limit of h approaches 0. Limit as h approaches 0, right? What is f of x plus h? It's this whole thing over here that I was solving for. So let's substitute it in. 2x cubed plus 2h squared, h cubed, my bad, plus 6x squared, h plus 6x, h squared plus x plus h, right? That's the first part. That's of x, that's fx plus h. What's the second part? It says minus f of x. So let me write it out. Minus, what is f of x? F of x is 2x cubed plus x. I'm putting it in a bracket because I don't want you to get confused or make a mistake. Make sure you put it in a bracket so that you do not forget to distribute
the negative side. So what's at the bottom? What's at the bottom is h. Right? So what do? One thing that you should always know that should happen for you to know that you have done it right is there should be at least one thing that cancels out. Right? So let's look at this. If I say negative 2 and 2x cubed, what does it mean? It means that they'll cancel out. So I'll have this and this cancel out. Right? And now I have x over there and I have an 8x over there too. But this is negative x because I multiplied the negative into the bracket. So this would be negative x plus x. That also crosses out. So what am I left with? Let me write it down. This is equal to the limit as h approaches 0. Again, you have to continue to write this until you have found your answer. So now what do I have? 2h cubed plus 6x squared h plus 6xh squared plus h. So I only have 4 terms left in the top, in the numerator, divided by h. Now what do? If you look at it carefully, you can already see the step that you need to do. You need to take out a common factor of h. Why? Because I can't substitute h is equal to 0 because there's a h at the bottom, and the h at the bottom cannot be 0. If it's 0, that means that it's undefined and I can't solve it. So that's why I have to find the common factor in the top, in the numerator, right? Approaches 0, then I take out h. So this will be 2h squared plus 6x squared h, plus 6xh plus 1 over h. So now look at this. That looks beautiful, doesn't it? Why? Because I can cross out this h and that h. And what am I left with? And I'm just left with that term over there. So let's write what that term is, which is equal to limit as h approaches 0 of 2h squared plus 6x squared plus 6xh plus 1. This is what I'm left with. Right? This is what I'm left with. That's the only thing that's left. So what do I do now? Is there an h at the bottom? No, there isn't, because it just canceled out. So now I can substitute the value of h, which is 0. Why? Because there won't be an undefined. So what will h be? So if I substitute, let me substitute it here, equal to 2 of 0 squared plus 6x squared plus 6x times 0 plus 1. Right? This is equal to, as you can see, I did not write limits over here. Why? Because I substituted what the limit value is. Right? So now I can evaluate this. This will be 0. This will be 0. Right? So what am I left with? 6x squared plus 1. Right? I hope you can see that this says 6x squared plus 1. In the later stages, you will see in the next section, which is using the differentiation rules, you will see that you can test your first principles answer using those rules to see that this 6x squared plus 1, is it correct? So let's go to the next step. Let's go to the rules. The rules of differentiation. Look at that linear line that's increasing. Anyway, so what's the first rule? So rule 1 states that it says that the derivative of a constant is equal to 0. So derivative of a constant, example C, is equal to right? That's the first rule. It's a simple rule. So if you're deriving a constant meaning a number like 2 or 3 or 4, it's equal to 0. Derivative of 20, 0. Derivative of 3, 0. Derivative of a million, 0. Right? So what's the rule 2? right? Rule 2 is the power rule. The power rule is one of the most used rules when it comes to differentiation. What does it say? What does the power rule say? The power rule says if f of x or g of x, let's write it as g of x, is equal to x to the power of n, right? The derivative of this is, which will be written as g prime, is equal to g prime of x is equal to n, let me write it in a different color. It will be n x to the power of n minus 1. Right? As you can see, that is the general rule that you apply when using the power rule. So when you have anything that is, let's say, x squared, you have to use this rule over here. We'll do an example later on. So that is, you have to remember that. You have to commit that to memory. It has to come to you as second nature. Right? So let's move on. Let's go to rule 3. There's a couple of these rules. There's 5 of these rules. But as you go through them, you'll realize they're not so bad. Like the first one is just the derivative of a constant is equal to 0. That there is not a rule. It really is something that you should just know. Right? Rule 3. What does rule 3 say? Is the derivative of a function multiplied by a constant. That's a rule. So derivative rule 3, derivative of a constant multiplied by a function. What does that equal? So what they're saying basically is if f of x is equal to, c, which is a constant, multiplied by, let's say, g of x, right? The derivative of this, which will be f prime, is equal to f prime of x is equal to c g prime of x, right? So it'll be just c times g prime of x. So what that means is that we can ignore the constant as we find the derivative. It does not change anything. So in this instant, the constant does not become 0. Why? Because there is a function. It's a function of something. It's a function of x. So this is not just a constant. So that rule only applies when it's just a constant. But as soon as it becomes, example 6x, it's no longer a constant. There's a coefficient that's a constant, but the whole term is not a constant. So it'll be, we have to use this rule here, which is derive whatever the function of is. So 6x, you derive the x. And then you multiply by the constant, which will be 6 once you have found the derivative. That's rule 3. So now we're going into rule 4. Rule 4 is the sum rule. Alright? So this is the sum rule. So what does the sum rule say? The sum rule says if f of x is equal to g of x plus h of x, the derivative of this f prime would be equal to f prime of x would be equal to g prime of x plus h prime of x. So basically what that says is that you don't do anything, you find the derivative of them separately. So you first find the derivative of g of x, or you first find the derivative of h of x, and then you combine them with whatever sign they have, which is the plus. So the other rule, on the opposite of this would be the subtraction rule or the reduction rule, which would be rule 5, which they call a difference rule. Right? They call it a difference rule, but you can call it whatever you want, as long as you know the concept. Because I'm pretty sure they're not going to ask you what is it called. So anyway, so let's go. So what does it say? It says if f of x is equal to g of x plus h of x, then the derivative f prime of x would be equal to g prime of x, minus, yeah, it's a difference rule, minus h prime of x. So what is this saying? What is this telling us? what it basically is telling us that you have to find the derivatives of the different functions separately, and then you just subtract them. So these two rules, the sum rule and the difference rule, are very similar. It's just there's a difference there's a negative sign between them, and there's a positive sign in the sum rule. So now let's do an example so that we can really grasp the concepts of what I'm saying. So example 1, let's look at it. So what does example 1 say? It says f of x is equal to 2x cubed plus 2x minus 3x squared plus 2. Right? So this is my equation. And the question says find f prime of x. Find f prime of x. What is f prime of x? F prime of x is the derivative of the function f of x. So let's do that. Let's find what f prime of x is. So since I know I'm about to start deriving, right, I write f prime of x. If you write f prime of x and you haven't derived it, then your answer will be wrong. So for example, if I say f prime of x is equal to, and I rearrange this formula here, and I say 2 plus whatever, that would be wrong, because that is not the derivative. That is still f of x. So keep it as f of x until everything is in order that you can derive. Like remember when you have to bring your x to the top and getting rid of surds, all those things, you have to do them before you write f prime of x is equal to. So now what do? Right, I'm deriving. So let me use the rules. The rule says that if I have, there are two things happening over here. There's rule of the derivative of a constant is multiplied by a function, which is rule 3. And I also have the power rule. So I have to execute two rules in the same term. So what's the first one that I do? What do I know about the multiplying rule? I keep the number there, and then I multiply after I found the derivative. Right? And then for the power rule, what do? So I'm going to put the 2 on the outside here. And then I'm going to make a bracket, right? And then I'm going to say 3, right? Because that's what the formula says. It says n, you bring whatever the exponent is down, multiplied by x to the power of n minus 1. So what is n? 3 minus 1. So that's what I have now, right? I haven't simplified this, but this is the derivative. I just need to solve it. So for the next one, let's go to the next one. Plus 2x. What did I say? That's what one of the big rules that's in here is the sum rule and the difference rule. Right? It says that you have to find all of your different differentiations separately, which is what I'm doing right now. Right? So plus in between, right? And then I'll find the differentiation of 2 of x. 2 of x, when x is just written as x, it means that it's to the power of 1. Right? So you can add that little 1 over there. If 2 is written like that, it means it's to the power of x is equal to the x to the power of 0, because anything to the power of 0 is 0. That's what that means when there's a constant. So let's do 2x to the power of 1. X to the power, so again, multiplication rule, I keep the 2 on the outside, make a bracket, and then I say I bring the 1 down. So there's the 1 here. And then I say multiply by x to the power of 1 minus, what is that? That's 1 is n minus the constant, the 1 that we always minus with, right? And then we go to the next one, minus. Again, this is the difference rule. I keep the negative there, then I find the derivative of the other thing on the other side. So this will be 3, right? And this becomes 2. So now what do? Again, it's the power rule. So I multiply, I bring down the n, then I make it x, then I'll say 2 minus n, which is n minus 1, right? The last one, I can't write it down as 2. Why? Because if I write 2, that means that's not the differentiation of 2. The differentiation of a constant again is 0. Let me show you why. Because remember we said that this is the same as 2x to the power 0. Because x to the power 0 is still 1. So let me write it down like that. So this will be 2, right? Let's use the multiplication rule, right? This will be 2, and then we put a bracket. So the power of 0, x is to the power of 0, right? So x to the power of 0, so we multiply by 0, and then we write x right? So since it's going to be 2 times 0, we know that this is going to be 0, which is why the constant, differentiation of a constant is equal to 0 as stated above. So there's no need for you to write this. There's no need for you to do this whole step here. You can do this whole work in your head, but it's always good to write it down so that you don't make a mistake. So now let me simplify this. This will be 6x squared plus 2 minus 6x. Okay, let's look through it, right? I say 6x squared. Why? Because 3 minus 1 becomes 2. 2 times 3 is 6 plus 2. Why is it just 2? Because 2 times 1 is 2, right? X to the power of 1 minus 1. What is that? That's equal to 0. X to the power of 0 is equal to 1. Anything to the power of 0 is 1. So it'll be 2 times 1 times.
Be happy and be you. You don't have to be anyone else. You don't have to compete with anyone else but yourself.
1, which is 2. And the last one is negative 3 times 2, which is 6. And x to the power of 2 minus 1. 2 minus 1, it gives me, what is that? 2 minus 1, what does 2 minus 1 give me? It gives me 1. So this is x to the power of 1. But I don't have to write x to the power of 1 because that's not necessary. We already know that and we assume that. Right? So that's basically it. That's the example on the rules of differentiation. So let me show you another couple of things that you will need to know that they might try to trick you with. Right? Let me show you that. Right? There are different ways they might show a differentiation. So let me write it down. So the first way is f of x. Right? They give you a function of f of x and then they say find the derivative of this, and then you just write it as f prime of x. Right? This is the way that you already know. Excuse my f, it's fighting with me. Okay, f prime of x, right? That's the way you already know. You know this already. So what's number 2, you ask? The step 2 is they give you in terms of y. They give you in terms of y. So they say y is equal to. What is y equal to? Y is equal to whatever the function is in terms of x. That's what we're working with. It could be in terms of other things, but in this certain thing we are working with, y is equal in terms of x. So what is the answer? What's the differentiation of this? The differentiation of this, you don't solve for when you're still trying to fix your equation so that it's differentiable. You first keep it in terms of y. You say y is equal to until you get to the point where you want to differentiate. And then when you actually differentiate, that's when you bring in dy over d of x. Right? And that is your differentiation. Dy over d of x. That's your differentiation. Right? So that's number 3. Now that's number 2. Number 3 looks a little bit complex, but it really isn't. It's just a different way of showing it, which still gives you the same result. So what is that way? Right? It says it's given as dx, capital dx is equal to, capital dx, and then in brackets, the function. The function will be inside the bracket. Right? So it'll be, they'll say they'll just write dx, and then they'll write the function on the inside, and then they'll expect you to know what to do from there. So how do you do this? We do this here by you continuously modify until the function is differentiable, right? Once the function is differentiable, while continuing to write dx, so you write dx with the function inside while you're making it differentiable, and then when you actually differentiate, then you leave the dx alone. And so then it will just be dx of whatever the function is equal to, and then you write your differentiation. So you continue to write this down all the way until you differentiate it, right? There's the fourth one is very similar to the last one, but this one is d over dx of a function. So this is d over dx of a function. But if you look at this carefully, this looks very similar to
to the one above. What is the one above? The one above says not just above, a little bit above, the dy over dx. So it's saying d over dx. D over dx is saying that d, that means that the y is inside this bracket. That's the function. So the function is inside the bracket. So what are we saying now? We're saying that you carry on to write you continuously write this all the way down until you differentiate it. Exactly like this one here. So when you finally find the differentiation, then you write d over dx, right, as the function is equal to, and then you write the differentiation over here. So that's basically the 4 different ways that they can show you the differentiation, and you should be able to still get those marks without any problems, right? Okay, that's the end of this derivative. So boom,